Good morning, one and all. Myself, Renuka. Today, I am going to explain about the topic recursive function. First, we will see the introduction of recursion. Recursive function is a function that calls itself to a solved problem by breaking it into smaller, simpler versions of the same problem. Let us see the definition of recursive function. Recursive function is the function that calls itself is called a recursion function. These functions are used when a particular subtask has to be performed repeatedly. These functions are implemented using iterative statements. It is used only in specific problems like finding, searching, and factorial. Basically, recursive function has two types, base case and recursive case. Let us see the definition of base case. A condition that stops the recursion. Without this, the function would call itself forever. Let us see the definition of recursive case. The part where the function calls itself with a smaller or simpler input. Next, let us see a uh, base case concept. Base case is the stopping condition in a recursive function. It tells the function when to stop calling itself, preventing infinite recursion. Next, let us see what the base case does. It stops the recursion and also provides a simple, direct answer to the smallest version of the problems. It ensures the recursive chain can eventually return a result. Next, why base case is important? Without a base case, the function calling itself forever, causing a stack overflow error. Next, let us see the definition of recursive case and what it does. The recursive case is the part of recursive function where the function calls itself with a smaller or simpler version of the original problem, and it is also the workhorse of recursion. This is where the problem keeps breaking down until it reaches the base case. What the recursive case does, it recursive case breaks the problem into a smaller subproblem, and recursive case calls the same function again using that smaller input, and it also gradually moves the function closer to the base case. Next, let us see the example of recursive function. Factorial of a given number is the example of recursive function. First, we have to write hash include stdabove.h. Next, we have to write function call int fact int. Here int is the return type, factorial is the function name, int is the argument. Next, we have to write main function, and we have to declare n comma f. Printf, we have to write any number that we want to calculate. Next, we have to write scanf and format specifier and address. Next, here f is nothing but factorial of n. Printf factorial equals to percentage d comma f. Next, we have to write again function definition. Int fact int n. If n equals to 0, it returns the value 0. Else if n equals to 1, it returns 1. If the condition is false, it will go for the statement return equals to n into factorial of n minus 1. Let us see the example of factorial. Let us take n equals to 5. 5 equals to 1. The condition is false, so it will go for the condition return equals to n into factorial of n minus 1. 5 into factorial of 4 equals to 120. Next, again n equals to 4. 4 equals to 1 is the condition is the false, so it will go for the statement return equals to n into factorial of n minus 1. Up to the condition is true, it will execute. Next, how the recursion works. Each recursive call is stored on the call stack. Recursion works by having a function call itself repeatedly, each time with a smaller or simpler input until it reaches a base case that stops the process. Here we can see the step-by-step explanation. The function starts running. When you call the recursive function, it begins just like any normal function. It checks for the base case. If the base case condition is there, it stops and returns a value. If there is no base case, it moves on to the recursive case. Next, let us see the example advantages of recursion. It is very simpler, cleaner, and more readable code. For problems that naturally break down into smaller versions of themselves, like trees, graphs, or net-state structures, recursion makes the code shorter and more intuitive. Let us see the example. Navigating a folder with subfolders, it is easier recursively than with loops. It is also ideal for trees and graph traversals. Recursion is a natural field for searching trees, exploring graphs, handling hierarchical or nested structures. Next, it is also used for matches the mathematical definition. Next, let us see the disadvantages of recursive function. It has recursive function has a higher memory uses and it has a high risk of stack overflow. It is also often slower than iteration. Thank you. This is the topic about recursive function.